back, students. Standard 10th Maths, chapter number 6, triangles. This is the fourth part. Alright. We'll just recall what we learned in the previous part. That is congruent triangles and similar triangles. The difference. Well, for a given correspondence, ABC corresponds to PQR between the vertices of triangle ABC and triangle PQR if corresponding angles are equal or congruent and corresponding sides are also equal and congruent. Equal or congruent, right? But what is the difference here? For a given correspondence, ABC corresponds to PQR between the vertices of triangle ABC and triangle PQR if corresponding angles are congruent. It's same here. See this, corresponding angles are congruent, but here corresponding sides are congruent, and here corresponding sides are in proportion. See the difference, right? Once again, for a correspondence between the vertices of two triangles, if all the corresponding angles and corresponding sides are equal or congruent, then the correspondence is congruence. For a given correspondence between the vertices of two triangles, if corresponding angles are equal and corresponding sides are in proportion, then the correspondence ABC corresponds to PQR is said to be similarity. Children, when these conditions are satisfied, when all corresponding six parts are equal, then the triangles have same shape and same size. They have both. The shape and size of the two triangles are same. That means the two triangles are coinciding, and when the two triangles coincide, they are congruent. But here only same shape, only the same shape. Sizes are different. Sizes are different. Then the two triangles are said to be similar. So when these two conditions, number one, corresponding angles are equal, number two, corresponding sides are in proportion, then if you try to overlap, if you try to coincide the two triangles, they will never coincide, but they will have similar, same shape. Sizes are going to be different. Alright? Understood? That's why if the triangles are similar, they have same shape. So you cannot call them congruent. But if triangles are congruent, they not only have same shape but also same size. So you can say two congruent triangles are always similar. Remember, I told you from the point of view of examination, board examination, this true or false is very important. Every congruent triangles are similar, but every similar triangles are not congruent. The statement is true. Every congruent triangles are similar and every similar triangles are congruent. The statement is false. Correct? Every congruent triangles are similar. True. Every pair of similar triangles are congruent. False. Is that clear to you? Okay, fine. Then we saw the shortcuts, right? The conditions for two triangles to be congruent. If two sides and included angle of one triangle are congruent or equal to the corresponding parts of the other triangle, then the correspondence is congruence. If two angles and included side, दोनों के बीच वाली, right? Okay, of one triangle are congruent to corresponding parts of the other triangle, then the correspondence is congruence. Here, two angles, and the side is not between the two angles. Two angles and a side, not included side, and a side of one triangle are congruent to the corresponding parts of the other triangle, then the correspondence is congruence. Thus, if all three sides of a triangle are congruent to the corresponding sides, corresponding parts of the other triangle, then the correspondence is congruence. Here, R for right angle. So for two right angled triangles, if hypotenuse and a side of one triangle are congruent to the corresponding parts of the other triangle, then the correspondence is congruence. Is that clear? यदि ये तीन पार्ट इस ऑर्डर में congruent हुए तो remaining three part automatically congruent. That means all six parts are congruent, so the two triangles are congruent. If these three parts are congruent, then the remaining three parts are congruent. Same thing applies for all these conditions. So these are the five conditions where when satisfied, the two triangles become congruent. Now the conditions for similarity of two triangles. We have in the textbook theorem 6.3, theorem 6.4 and theorem 6.5. Theorem 6.3 is AAA condition for similarity. AAA criterion. Or it is also called corollary. Either you can say AAA criterion or corollary, SSS criterion. It's theorem actually. It is theorem. This criterion or corollary also is called in some books. Alright? In your book it is statement. The statement is in the form of theorem. Okay, anyway. Now what is AAA condition for two triangles to be congruent? We have seen by definition, if corresponding angles are equal and corresponding sides are in proportion, then the correspondence is a similarity. But by theorem 6.3, you can say if corresponding angles are congruent, that means only first condition is satisfied. You do not know anything about their corresponding sides. Doesn't matter. If corresponding angle, if corresponding angles are congruent, then automatically corresponding sides are in proportion. That means the two triangles are similar. Alright. Here, I've got one triangle. Children, I've got one triangle. Okay? I think I'll remove this part now. Not required. Okay? Here is triangle. What is the triangle? X, Y, Z. This is 80 degree. This one is 40 degree. And this one is 60 degree. Correct? Alright. I have another triangle. Here. This one is 80. This is SIM. This one is 40 degree. And this one is 60 degree. So you can say angle X 80, angle S 80. So X is equal to angle S. 60, 60. So angle Z is equal to angle I. And 40, 40. Angle Y is equal to angle M. So correspondence. Correspondence. Which one? X, Z, Y. X, Z, Y corresponds to SIM. SIM is a similarity. Children, how can you say this correspondence is similarity? Because you know corresponding angles should be congruent and corresponding sides should be in the same proportion. But here only corresponding angles are congruent. Then how do you say it is similarity? By theorem 6.3, which says it is AAA theorem. Let's see. They are not congruent, they are not overlapping, but the shapes are same. Both the triangles have same shape. How do you recognize that? How do you identify that the shapes are equal? This edges, you see corresponding sides. They are parallel. Corresponding sides are parallel. Corresponding sides are parallel. Not only that, this thickness, the perpendicular distance between the parallel side is constant. Then you can say the shapes of the two figures are equal. Here the two figures are two triangles and they have similar shape. So these two triangles are similar. Children, here also I have got one triangle. See this? 80, 60, 40. 80, 60 and 40. 80, 60 and 40. See 80, 60, 40. So again AAA is satisfied. But here the two triangles are congruent as well. but they are not always congruent. They are not always congruent, children. You can see now these two are not congruent. These two are not congruent, but they are similar. This yellow and blue, they are similar, correct? But the yellow and this blue are not congruent. Yeah, this blue and yellow are congruent as well. But whenever angle is satisfied, the shapes may be same, the shapes may be not same. Sorry, I made mistake. The sizes may be same or sizes may be different. Sizes may be different. So if sizes are different, then they are not congruent. So they are not always congruent. In short, when A condition is satisfied, the two triangles are similar. Is that clear? And that is theorem 6.3. Okay. Next condition for similarity of two triangles is S. Only this condition, not this. And remember, sides are not equal. Sides, corresponding sides are in proportion. Let's see. I've got one triangle here. This triangle, somewhat like this. PQR. This is 15 centimeter. This is 10 centimeter. And measure of this angle is 80 degree. Alright. There's one more triangle here. This triangle is ABC. This is 12 centimeter. This is 18 centimeter. And this angle is 80 degree. Alright. Children, by mistake I have picked up this. So let's see that. Doesn't matter. Okay. Now see, children. What is that? Angle R equal to angle C, because they are equal. And let's find out what is PR upon AC. PR upon AC. What is PR? 15. What is AC? 18. 3 5s are 3 6s are. So what is PR upon AC? 5 upon 6. Let's find out what is QR upon BC. QR upon BC. QR is 10 and BC is 12. 2 5s are 2 6s are. That is also 5 upon 6, children. That is also 5 upon 6. So you can say PR upon AC is equal to QR, this one, upon BC. PR upon AC is equal to QR upon BC. So all three corresponding sides are not in proportion. Only two corresponding sides are in proportion. So these two corresponding sides are in proportion. And which two sides? PR and QR. PR and QR. Which is the included angle? R. Same way. Here which sides? AC and BC. AC and BC. And which is the angle included by these two sides? Angle C. Yes. So we have two corresponding sides in proportion and the included angles are equal. Then by SAS condition, the correspondence is a similarity. By SAS condition, the correspondence is a similarity. Children, what is the difference between this SAS and this SAS? Here, two corresponding sides are equal and included angle is also equal. Here, two corresponding sides are in proportion and the included angles are equal. Then the correspondence is similarity. In this case, the correspondence is congruence. Did you get me? Sure. Okay. Let's check out. देखो 18, 12 और 80, 15, 80 और 10. See, आप किसी भी तरह try कर लो. They will not be coinciding. But if you arrange it nicely, say this corresponding sides are parallel and the thickness is uniform, same. So that means the blue and yellow triangle are having similar shape. That means they are similar triangles. Is that clear? I've got one more triangle here. correct? Yellow one. 15, 10 and 80. See that yellow one is congruent to this. Now they are congruent, but they are not always congruent. Matlab, if this condition is satisfied, the two triangles may be coinciding, the two triangles may not be coinciding. So you cannot say if this condition is satisfied, the sizes also would be the same. That means you cannot say they will be congruent, but you can definitely say they will be similar. So this is the second condition. Okay. Now next condition we'll see. Alright. Let's see. Here is one triangle ABC. ABC. Measure of this side is 12, this is 16 and this is 20. Alright. And there's another triangle PQR. PQR. Alright. This side is 6 centimeter, this is 8 and this is 10. Children, these measures are perfect. I have cut according to the measure written here. Alright. Now, which condition is satisfied? Let's see. Children, which is the smallest side? 12. And here smallest side? That means AB. And here smallest side PQ. So let me take AB upon PQ. So that is 12 upon 6. 6 ones are 6 twos are. So answer is 2. Now second smaller side is BC. And here it is QR. BC is 16 and QR is 8. 8 ones are 8 twos are. So answer is 2. The largest side is 20, which is AC. And the largest side here is 10, which is PR. So 20 upon 10, 0, 0 cancel, that is 2. Hooray! All three corresponding sides are in proportion. So this condition is satisfied. Theorem 6.4. Are they similar? Let's check. देखो 6 को 12 के साथ, 8 को 16 के साथ और 10 को 20 के साथ. Can you see that? Parallel sides, corresponding sides are parallel and the thickness is also same. So they are similar. So these are the three conditions for similarity of two triangles. I'll say now, for a given correspondence between the vertices of two triangles, if corresponding angles are equal or congruent, then the correspondence is a similarity. This, for a given correspondence between the vertices of two triangles, if the corresponding sides are in proportion, then the correspondence is a similarity. And the third condition, for a given correspondence between the vertices of two triangles, if two sides are in same proportion and the included angles are equal, then the correspondence is a similarity. Got that, children? So whenever we have to show that the two triangles are similar, we'll be using this condition, but we will never be using this condition, though it is true. Why we will not use this condition? Still shorter result we get from there. Please try to understand. Please try to understand. This is triangle ABC. Measure of this angle is 90. This is 40 and this is 50. Alright. Now look here. This is another triangle. Right angle triangle. It's a bada hai. Right angle triangle. And this is 40 degree. You don't know the third one. Let me say this is PQR. So what do you have from here? Okay, this is also not the only two. Angle A is equal to angle P. Angle B is equal to angle Q. Children, what is A? 90. What is B? 40. So what is the total? 130. Remove 130 from 180, 50. So you got the third one. What is the measure of third one? 50 degree. Same way you find here. What is P? 90. What is angle Q? 40. Total 130. So what will be measure of angle R? 180 minus 130. That is 50. So this is again 50. So if two corresponding angles are congruent, then the third corresponding angles automatically become congruent. Chali, measure of one angle is 100, the other is 20. We do not know third. Another triangle, measure of one angle is 20, the other one is 20. We do not know third. So here only AA, not AAA, only AA is satisfied. But if AA is satisfied, then AAA is automatically satisfied. बोलो दोनों का total 120. 180 में से 120 निकालो 60. So this also would be 60. So now if AA is satisfied, then AAA is automatically satisfied. So there is no need to show that all three corresponding angles are congruent. You can show any two corresponding angles congruent and the two triangles become similar. Children, this is called AA criterion. इस कंडीशन को क्या कहते हैं? AA criterion or AA corollary. AA criterion या AA corollary. Why we shall never be using AAA, that is theorem 6.3. Easier than that is AA criterion. If two corresponding angles are congruent, all three corresponding angles, the third corresponding angle also would be congruent. So here we need to show only two corresponding angles congruent. That is short, that is quick for us instead of showing all three. Correct? So whenever we will be showing two triangles similar, the shortest and sweetest method is AA criterion, AA corollary. Yeah. If the condition satisfies this, theorem 6.4, 6.5, we can use that. SSS. So if this is satisfied by SSS, the two triangles are similar. Only two corresponding sides are equal. ये दो ही equal है. So angle and angle B is congruent to angle Q. देखो PQ और QR में Q included angle. AB और BC में angle B included angle. If this and angle B is equal to angle Q, then the correspondence is similarity by SAS. I hope you understood that. Okay. Now let's see how we can prove two triangles similar. Either use AA corollary, SSS theorem, या SAS theorem. This SAS theorem is totally different from this. This SSS theorem is totally different from this. Here, two sides and included angle are congruent. Here, all three sides are congruent. Here, two sides are in proportion. Here, all three sides are in proportion, not equal. Is that clear to you? Alright then, let's see the next statement. It is of theorem 6.7. Alright? Children, please try to understand the statement well. And if you have done with that and drawn the correct figure, I think it's very easy to prove. Alright? So, sometimes you need to read a couple of times to understand the statement well and get the correct diagram, correct figure. Alright? So, let's read and try to understand. If the perpendicular is drawn from the vertex, what is drawn? A perpendicular. It's also called altitude. Drawn from what? Vertex. Vertex is one corner of the angle, correct? Or one corner of the triangle. Vertex of right angle. Vertex of right angle. Of right triangle. So here we come to know. We have a right triangle. One of the angle is right angle. That vertex. From that vertex you draw perpendicular. Kaha? To the hypotenuse. That perpendicular has to be drawn from vertex to the hypotenuse. Then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. It's little bit difficult to understand, but when you draw the figure properly, it's quite easy. See, I hope at least you came to know it's a right angle triangle. One right angle triangle is given. So here I am drawing a right angle triangle. Let's say this is triangle ABC and angle B is right angle. Angle B is right angle. If a perpendicular is drawn, so we are going to draw perpendicular from the vertex of right angle, which is right angle B. So which is the vertex at which right angle is there? B. From the vertex of right angle, of a right angle triangle. Yeah, right triangle. Here is right triangle. Right angle is at B. So vertex is point B. To the hypotenuse of the triangle. To the hypotenuse. Which is the hypotenuse? AC. यहाँ से आपको perpendicular draw करना है. Let's say this is B, D. The green line segment is perpendicular, drawn from vertex B to side AC. Vertex B is the vertex at which right angle is formed, and side AC is hypotenuse. Did you understand, children? Once again, if perpendicular is drawn, what is drawn? Perpendicular, which is green line segment, from the vertex of right angle. The right angle is B, so vertex is point B of right triangle to the hypotenuse. Yes, that perpendicular is drawn to the hypotenuse. Then if so many conditions are given, what is the result? Then triangles on both sides of perpendicular. Children, which is perpendicular? The green segment. So this triangle ABD, the blue triangle that I have drawn, is on one side of perpendicular, and the red triangle that is on the other side. Correct? Then triangles, CS plural, triangles, more than one, two triangles. One is blue, the other is red, on the sides of perpendicular. Correct? Green segment is perpendicular, on one side blue triangle, on other side red triangle. Then the triangles on both sides of perpendicular are similar. Means the blue triangle is similar to red triangle. Okay. Are similar? Sorry. Yeah. First, this blue and red triangles are similar to the whole triangle. The whole triangle is the black triangle. Children, be careful. Triangles, that means the blue one and the red one, are similar to the whole triangle. Whole triangle is the black one, ABC, the whole triangle. Correct? So blue triangle is similar to whole triangle black. Red triangle is similar to whole triangle black and to each other. And that blue and red are similar to each other as well. Are you getting me? Children, please be careful. I'm writing the data first. Data. Angle B is a right angle in triangle ABC. Angle B is a right angle in triangle ABC. Correct? You have right angle triangle. Or triangle ABC is right angled at B. You can say that. And BD is perpendicular to AC such that A dash, D dash, C. The foot of perpendicular is on it. A dash, D dash, C. Bas, so much is given. Angle B is right angle in triangle ABC, and a BD is perpendicular to AC, the hypotenuse. BD is perpendicular drawn from vertex B to hypotenuse AC. To prove, children, one, the blue triangle, I am writing a blue triangle, ADB, that right angle I am keeping in the center. Triangle ADB is similar to the whole triangle ABC. Alright? Or let me write like this, that would be better. Triangle ABC is similar to blue triangle ADB. Alright? You might write ABD, ADB, whatever. Second that you have to prove. Again, the whole triangle ABC is similar to red triangle BDC. Red triangle BDC. You may write BDC, DBC, CBD, anything. But that right angle I am keeping in the center, if you notice that. Okay. And third, the blue triangle blue triangle ADB is similar to red triangle BDC. Once again, I am going to read the statement for the final time. So I hope if you have any doubt, it will be totally clear. If perpendicular is drawn from the vertex of right angle, of right triangle. So here is right triangle, angle B is right angle. So vertex is point B. If perpendicular is drawn to the hypotenuse, yes, BD is perpendicular to hypotenuse AC. Then triangles, the blue triangle and red triangle, on both sides of perpendicular are similar to whole triangle, the black triangle, whole triangle, and they are also similar to each other. They are also similar to each other. I hope you all have understood. Sure? Okay. Can I remove the statement now? Because I'll have to write the proof. Correct? Chaliye. I'm removing the statement. I'm starting the proof from here. First, I have to show black triangle ABC is similar to blue triangle ADB. Very interesting, children. We have three conditions to show that the two triangles are similar. Shortest and simplest one. AA criterion, then side angle side theorem, and three angle SAS, and one more, which is that SSS. Correct. Okay. I'll write on the side. AA criterion, side angle side, and SSS. We should always try AA first. Alright? Now look at the blue triangle. In blue triangle, angle D is right angle. Is that? And in black triangle, angle B is right angle. So you got in triangle black. First I'll write black. In triangle ABC and triangle ADB. Yeah, I had written ADB only. ADB. Bole, angle B. Angle B is equal to angle D. Angle D. You will write reasons why they are equal. Both are right angles. That's why. You children, you got one angle. If you succeed to show one more pair of corresponding angles equal, then AA criterion is satisfied and the two triangles become similar. एक और pair of corresponding angles equal देख लो children, आपको दिखता है एंगल. देखो यहाँ ब्लू और ब्लैक लाइन दोनों है. Can you see? Angle black, that is BAC. Angle black, BAC, पूरा नाम दे रहे हैं. And angle blue, BAD. Are they equal? Sure. Why? Because A dash, D dash, C. So ray AD, ray AC, ray CD, whatever, it's one in the same. So angle BAC and angle BAD, they are common angles. They are one in the same angles because of this betweenness, A dash, D dash. So I am writing that angle black part I am keeping on left hand side. Angle BAC. Angle BAC is equal to angle BAD. Blue one. BAD. Reason, common angles, comma, A dash, D dash, A dash, D dash, C. Given. Correct? A dash, D dash, C is given. It's there. A dash, D dash, C. Right? Here children, finished. Two corresponding angles are congruent. So I can write. Therefore, a कॉरेस्पॉन्डेंस। ब्लैक का एक ऑर्डर में लिख दू, ब्लैक ब्लैक पार्ट ए बी सी कॉरेस्पॉन्ड्स टू डैश 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 इज अ सिमिलैरिटी बाय ए क्राइटेरियन या ए कॉरलरी। करेक्ट। अब मुझे वो ब्लू लिखना है, ये दोनों कॉरेस्पॉन्डिंग एंगल ही है, सो डायरेक्ट कॉरेस्पॉन्डेंस यू गेट। ब्लैक बी here in the center corresponds to D, so B is in the center, so D has to be in the center. चिल्ड्रन यहां भी आपको सेंटर टू सेंटर देखना पड़ेगा। ब्लैक A corresponds to या congruent to blue A. Black is first in the order, so blue A should be in the order. Now fill in the blank. ब्लू ट्राइंगल में A D B, A और D आ गया, बच गया B, fill in the blank कर दो। B is similar. IE. Now put symbol of triangle. Triangle ABC is similar to triangle ADB. Proved. One is proved. Triangle ABC is similar to triangle ADB. Children, यहाँ ABD आ गया तो ट्राइंगल सिंबल के बाद आप चेंज करके इसके साथ मैच कर सकते हो। इवन इफ यू डोंट डू इट्स ओके, क्योंकि ट्राइंगल सिंबल के बाद मैंने बताया था कि आप कुछ भी लिख सकते हो। कुछ भी मतलब ABD, DAB, BAD, यहीं से ये तीन लेटर जिस ऑर्डर में लिखना चाहते हो लिख सकते हो, बट ओनली आफ्टर पुटिंग द सिंबल ऑफ ट्राइंगल। बट दैट्स इनफ, ओके फाइन। सो फर्स्ट थिंग इज प्रूव्ड। नाउ सेकंड, ब्लैक इज सिमिलर टू रेड, सो अब इन ट्राइंगल ब्लैक एंड रेड वो लेना पड़ेगा। इन ट्राइंगल ब्लैक दैट इज ABC एंड ट्राइंगल रेड, उसका नाम क्या लिया है हमने? BDC। ट्राइंगल BDC। ए चिल्ड्रन, once again this is right angle and black angle B is right angle, so you can say angle B is equal to angle D. Reason, right angles, correct? And do you have one more pair of corresponding angles equal? Which one? Yes, red angle, black angle, angle C. यहाँ blue A, black A, red C, black C. अब black C का नाम क्या होगा? Angle C, if you consider the whole triangle, ACB, angle ACB is equal to, red का पूरा नाम क्या होगा? C को सेंटर में आना चाहिए, DCB, या you can say BCD, जो भी कहो कोई बात नहीं। Angle BCD. Reason, common angles, common, or you may write just A dash, D dash, C, given. ये भी लिख सकते हैं, दोनों में से कोई भी एक, या दोनों लिख सकते हैं, जैसे यहाँ लिखा। मेरे पास कम जगह है इसलिए मैंने एडजस्ट कर लिया। हो गया। For black triangle ABC, whole triangle ABC and the red triangle BDC, two corresponding angles are congruent. A criterion is satisfied. Therefore, a correspondence, black का सेम लिख लो, ABC corresponds to dash 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 is a similarity, by AA criterion, all right? चलिए, yes, दोनों एंगल ही है, डायरेक्ट मिल जाएगा। B corresponds to D because angle B is congruent to angle D. B बीच में, so D बीच में लिखो, यहाँ बीच वाला। C corresponds to C, angle ACB is congruent to angle BCD, so C corresponds to C. C is in the third order, so write C in the third order. C corresponds to C. Now red triangle is BDC, D और C आ गया, बच गया B, so write here B. Therefore, triangle, now put symbol of triangle, triangle ABC is similar to triangle BDC. By, okay, that we have already done, AA criterion. So this is proved. Children, you may take a screenshot of this and then you write down. I'm not giving you time to copy this. because I will continue. Third part, still we have to prove. We have to prove, no? Okay. Now see, please. I'll rub out the first part. Yes. Now look, from this correspondence, one I rubbed out, anyway. Blue, right angle blue is equal to right angle red. So blue or red triangle, blue or red triangle. In triangle blue का ये नाम दे देते हैं triangle ADB, और red, that is triangle BDC, all right. Two angles are right angles. Angle ADB is equal to angle BDC. Reason, right angles. Angle BDC, the reason is right angles. Children, इस रिजल्ट जो फर्स्ट कॉरेस्पॉन्डेंस आया उसे 1 कहेंगे, द सेकंड कॉरेस्पॉन्डेंस सिमिलैरिटी उसको कहेंगे 2. आई एम गोइंग टू एक्सप्लेन टू यू एंड वी आर गोइंग टू राइट डायरेक्टली फ्रॉम दिस 1 and 2 व्हाट यू गेट चिल्ड्रन, एंगल बी इक्वल टू एंगल सी मिलेगा, या एंगल ए इक्वल टू एंगल बी मिलेगा. बट ये कॉर्नर वाला, नीचे वाला एंगल बी एंड एंगल सी वुड बी इक्वल. सो ब्लू एंगल एबीडी and a red angle DCB are equal. कैसे? अब यहां देखो, this is blue angle B, blue angle B ये is congruent to black angle C. दिख रहा है आपको? यहां देखो, blue में blue angle B मतलब ये वाला is equal to black angle C, ये black angle ये. बट यहां देखो, ये black angle C equal to red angle C. That black angle C and red angle C are equal. So see that angle B is equal to angle C. So I am writing that blue angle ABD is equal to red angle BCD या DCB, angle BCD by 1 and 2. By 1 and 2 you get from there. Simplicity, alright? Finished. For blue triangle and red triangle, two corresponding angles are equal. Therefore, a correspondence, blue का लिख दूं, यहाँ जो भी हो, blue का ADB corresponds to dash 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 is a similarity. Once again, by angle criterion या corollary. ऑलराइट, अभी रेड का क्या आएगा देख लो, बीच में D corresponds to D बीच में तो रेड D भी बीच में आएगा, ब्लू D बीच में तो रेड D. नाउ ब्लू B corresponds to C, B is last so C has to be last. रेड ट्राइंगल में C और D आ गया, जो बच गया है वो therefore triangle ADB is similar. I'm putting the symbol of triangle BDC. This is proved, and did you understand? Okay, then let's see one illustration. That is the last example in this session. All right, but before we read this and try to understand, let's have a little practice of this because we'll need it desperately here. This is right angle triangle PQR, and RM is altitude. RM is altitude on hypotenuse. Then the original triangle PQR corresponds to what? All right, and original triangle PQR corresponds to what? And that the two remaining. Okay, triangle first, this is triangle second, triangle PMR is first, triangle RMQ is second, and the original triangle is triangle PQR. Please be careful. Dash 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 is a similarity by AA. Bole. Now I'm talking about this triangle. First one. Alright. Which is right angle here? M. And in triangle PQR, which is right angle R. R is last, so M should be last. Did you get me? Alright. Which is common angle? Blue and green, P. So P is first, P corresponds to P. So which is missing? P, M and R. So R is missing. That you write down. So PQR corresponds to PRM is a similarity. That's how you can get directly. Now I'm talking about this red triangle and the original triangle. Dash, dash, dash is a similarity. Again by AA. Actually by theorem 6.7 that we have seen. Okay. चलिए. ओरिजिनल ट्राइंगल में राइट एंगल कौन सा है? R. वो लास्ट में है. और ये ट्राइंगल में राइट एंगल कौन सा है? M. Correct? M is right angle. So R is last. So M should be last. And then common angles. Which are the common angles? Red angle Q and green angle Q. So Q corresponds to Q. And which is left? Q and M are over. R is left. So that is R. RQ. And this straight away you can write from here. PQR corresponds to this. PQR corresponds to here. Same hai. So you can say PRM corresponds to RQM. Same order. Okay. Is a similarity. Is a similarity. Here by AA. Actually, these angles are right angles, and if you remember, this angle is equal to this angle from this 1 and 2. So by AA corollary, you can prove that also. Had little practice how to write. Okay. Second thing, children. Say suppose you have equal ratios like this. A upon B is equal to B upon C. Ratio of this type, like 2 upon 4 is equal to 4 upon 8. They are equal. Can you see that? 4 4s are 16, 2 8s are 16. They are equal. So here, if you do the cross multiplication, what you get? AC is equal to B square. I.e. B square is equal to AC. Here, if you cross multiply, you get 4 square is equal to 2 into 8. When you have equal ratios of this type, denominator of the first ratio, which is called consequent, is equal to numerator of the second ratio, which is called antecedent. Let's say numerator, denominator, because you are familiar. Denominator of the first ratio and numerator of the second ratio are equal. Same. Then we can write B square is equal to AC. Same. Denominator, numerator same. So 4 square is equal to 2 into 4. So if you have B square is equal to AC, in verbal statement you can say B is geometric mean. B is geometric mean of A and C. B is geometric mean of A and C. Here 4 square is equal to 2 into 8. So 4 is geometric mean, I am writing in brief now, of 2 and 8. Is that clear? Now conversely, if I say X is geometric mean of Y and Z, uska matlab X square is equal to Y into Z. P and R, the geometric mean of P and R is Q. Geometric mean is Q. So Q square is equal to P into R. So please remember what is meant by geometric mean. Alright. Here ऐसा ही कुछ है. See, AB square is equal. AB is geometric mean of AD and AC. BC square equal to CD into AC. So BC is geometric mean of CD and AC. And BD is geometric mean of AD and CD. This is what we have to prove. Let's see the statement of this illustration now. If BD is perpendicular to hypotenuse AC of triangle ABC, then prove that. Okay, let's draw the figure first. It's a right angle triangle, so I'm drawing that right angle triangle. Hypotenuse AC. So this is AC, hypotenuse. So angle B is the right angle, and this is the altitude. BD. BD is altitude. Alright. So that's it. BD is perpendicular to altitude AC in right triangle ABC. This is data. And you have to prove these 3 results. Then prove that. Okay. So first I'll write data. What is data here? In triangle ABC, angle B is a right angle. You can say that because AC is the hypotenuse, right angle, and BD is perpendicular to AC such that A dash D dash C. Clear? Chaliye children, I am going to use theorem 6.7. I am going to use theorem 6.7. अच्छा, to prove लिख देते हैं. To prove first, second and third. I am not writing it here because they are here. Okay. First, AB square is equal to AD into AC. चलिए. AB is involved in this triangle. Correct? Now you know this green triangle is similar to whole triangle. Do you know that? Yes. So proof. I'll start with that. A correspondence. Red triangle ABC. ABC corresponds to dash 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 is a similarity by theorem 6.7. If you don't remember the number, don't worry, you write by theorem. Okay. Now which correspondence? Boliye. Green angle D and this angle B are right angles. So B is congruent to D. So B corresponds to D. And the common angle AA, green angle A and red angle A. So A corresponds to A. What is left out? AD and a B is left out. Correct? Is a similarity. Children, please be careful. Now this correspondence is similarity. So by definition of similarity, what you have? AB upon AD is equal to, bolo, BC upon BD is equal to, boliye, AC upon AD. Children, here one you don't require. यहाँ एक का काम नहीं है. कौन सा? देखो इसमें क्या है? AB AB. तो AB यहाँ है AB upon AD is equal to BC upon BD is equal to AC upon, yeah, see, AC upon AB. I wrote AD. Alright. So देखो AB है, repeating is AB. AB is repeating. So ये last में और first में. So we don't need this. Correct? आप इसकी जरूरत नहीं है. So तीनों लिखने की जरूरत नहीं है. What you will do? रेड ए बी लिख लो तो ए बी को कॉरस्पॉन्डिंग ए डी आ गया इज इक्वल टू. अब यहां से ए बी लिख दो, वो नीचे आएगा ए बी, तो यहां से कॉरस्पॉन्डिंग ए सी आएगा बाय definition of similarity. If correspondence is similarity, then corresponding sides are in the same proportion. Cross multiply कर दो. Therefore, AB square is equal to AD into AC. Proved. 1. Did you understand? The first one is proved. Is that clear to you? Are you getting me? चलो, ये correspondence को मैं रहने देता हूं. अब दूसरा correspondence, ये black triangle and the original triangle. A correspondence. ओरिजिनल ट्राइंगल अपना रेड है, मैं लिख देता हूं ABC corresponds to dash 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 is a similarity by theorem 6.7. We remember that right now. Okay, and the black triangle, देखो angle D is congruent to angle B, right angle. So B, the red one, corresponds to D. B बीच में, so D बीच में. And common angles are C, black and red C. So C last, C last. C और D आ गया, बच गया B. तो वो fill in the blank कर. चलिए. Now you know AB upon BD is equal to BC upon CD is equal to AC upon BC. लेकिन out of 3 we have to take only 2. अभी BC की बारी. BC यहां से ले लिया. ये लेफ्ट हैंड साइड का तो ऊपर रहेगा, सामने कॉरस्पॉन्डिंग CD आएगा. अभी BC यहां से मिल रहा है, वो नीचे लिखना पड़ेगा यहां से राइट साइड का. BC को कॉरस्पॉन्डिंग क्या होने वाला है? AC. क्रॉस मल्टीप्लिकेशन. Okay, this is by definition of similarity. Therefore, BC into BC, BC square is equal to CD into AC. This is proved 2. Proved 2. Is that clear? Is that clear? I'll remove this. आप स्क्रीनशॉट लेके इसका प्रूफ लिख सकते हो और आपको बुक में लिखना है. Be careful. So I'm giving you time to take screenshot. Or you can pause and write. Okay? अभी ये बहुत जरूरी है. This I am going to call it 1 और ये correspondence 2. देखो ABC left hand side पे. So by 1 and 2 it follows that same order ADB corresponds to BDC is a similarity. By 1 and 2 it follows that a correspondence कौन सा ADB corresponds to BDC is a similarity. अब आपको क्या चाहिए BD, यहां से BD मिला अपॉन यहां से लेफ्ट से BD को ऊपर लिखा, सामने कॉरेस्पॉन्डिंग CD मिलेगा इज इक्वल यहां से BD यहां मिला, वो नीचे आएगा BD, राइट वाला नीचे, BD को कॉरेस्पॉन्डिंग आपको AD मिलेगा. Therefore क्रॉस मल्टीप्लिकेशन BD square is equal to CD into AD या AD into CD. This is proved 3. I hope you all have understood that. Sure. So we end up this session here. We'll continue in the next.